I'm Anil Kumar. Welcome to my series on calculus. In this video, we'll discuss very important application, and that is to find tangents and normals. I will have three related examples. We'll talk about how to find the equation of tangent line, how to find equation of normals, how to find their intersection, and then the area of the triangle formed by the tangents or normals. Those triangles will be scalene triangles, and we'll see what type of formula can be applied to find the area. So all the three parts are very critical from any examination point of view. Let's look into this question here, which is the normals to the curve f of x equals to x cubed minus 5x squared plus 3x plus 1 at the points P 1, 0 and Q 4 minus 3 intersect at R. Find the area of triangle PQR. So what we are given here is the function f of x, which is equal to x cubed minus 5x squared plus 3x plus 1. We need to find the equation of normals first and then the point of intersection. So let's find the derivative that will give us the slope of the tangent. Derivative will be using the power rule 3x squared minus 10x plus 3. Let's find derivative at the point 1, 0. So the derivative at x equals to 1 will be 3 minus 10 plus 3. That is 6 minus 10, which is minus 4. Let's also find the derivative at 4. At 4, the derivative will be 3 times 4 squared minus 10 times 4 plus 3. And that is equal to 4 squared 16 times 3 is 48 minus 40 plus 3, which is equal to 8 plus 3, which is 11. So we know the slopes of the tangents at the given points, right? Now let's try to figure out the equation of normal, right? So we'll find normal equation at the point 1, 0, let's say, right? Now we know that the slope at this point P is equal to what? X equals to 1, the slope is minus 4. So the normal at P will be negative reciprocal or 1 over 4. So the equation of the normal will be y minus y1. So we are using this equation, y minus y1 equals to m times x minus x1, correct? So in this case, y1 is 0, so we can write this as y equals to the slope of normal, which is 1 over 4, times x minus 1. Or we get 4x equals to x minus 1. That's one of our equation. Let us also find the equation of normal at the point Q, which is 4 minus 3. Now, at point Q, which is 4 minus 3, the slope m at Q is equal to 11. So the normal slope will be equal to minus 1 over 11. And the equation will be y minus the y value of minus 3, slope minus 1 over 11 times x minus the x value of 4. So we could write this as 11y plus 33 equals to minus x plus 4. So we get this equation. Now we need to find the value of x and y. So let's take it to the next page. Let me simplify this and then we'll take it to the, sorry, this was 4y, right? So 4y is this. So from here, what we can do is that we can write what x is. So this gives you the value of x as equal to 4y plus 1, correct? We are going to substitute this value in the second equation. So we get here 11y plus 33 equals to, instead of x, I'm writing 4y minus 1. So we get minus 4y minus 1, that plus 1 becomes minus 1, plus 4, correct? We'll take it to the next page and then find the value of x and y. Okay. So let me rewrite the equations which we have got. So one of the equation is x equals to 4y plus 1. And when we substituted this into the other equation, which was 11y plus 33 equals to minus x plus 4. Right? So we'll continue from here. That is the last two equations, and then solve for the point R, which is the intersection of these two normals, right? So we'll rearrange and write the value of x. So we can get from here that 11y plus 33 equals to minus 4y minus 1 plus 4. Bringing all the terms to one side, we get 11y, rather y terms on this side, 4y equals to, we'll take this to this side, 4 minus 1 minus 33. So this is 15y is equal to, so minus 30, and so y will be equal to, sorry, minus 30. Minus 30 by 15, which is minus 2. So we get the value for y. And now we can substitute this value of y and find what x is. So x will be equals to 4 times minus 2 plus 1. So that is minus 8 plus 1 or minus 7. So the point Q will be minus 7 minus 2. Is that clear to you? So we have this point of intersection minus 7 minus 2. So now we are looking into 3 points. Let me just form this triangle PQR. So we have 1, 0, 4 minus 3 and minus 7 minus 2. So we could actually make a triangle which is kind of like this. Right. So where the point PQR can be written as, this point is P, which is, let us say, 1, 0. And then we have minus 7 minus 2 will be, no, this is the intersection point, I'm sorry, R. So R, the intersection of normals. Is minus 7 minus 2. Correct? So this is R for us, which is minus 7 minus 2. And that is Q, which is 4 minus 3. Okay. So we need to find now the area of this triangle. Now to find the area, we can use the formula, which is Heron's formula we can use, or we can use a cross product formula. So area of the triangle PQR is basically equal to half of x1 y2 minus y3 plus x2 y3 minus y1. So basically we have to go in a particular order, 1, 2, 3, right? So that is kind of important to maintain. So let me rewrite how do we maintain this order, right? So it is points 1, 2 and 3. So we are going in this order, right? So after 3 you get 1. So y3 minus y1, correct? Plus x3 times y1. So y, we have taken care of y2, y3, now it is y1 minus y2. Is that clear to you? So that is how we get the area. Let me just squeeze in here. So x1, we are taking the point 1, 2 and 3 in this order, right? So we have 1. So 1 time y2 minus y3, so which is minus 3 minus, that becomes plus 2, plus then 4 times this minus that, so which is minus 2 minus 0, plus next is minus 7, let me write minus 7, and then y values 0 minus 3, which is 3. So that is equal to half of, so minus 3 plus 2 is minus 1. Here we get minus 4 times 2 is 8. And here we get minus 21. Right. So what you see here is that we get a negative answer. But area should be what? Positive, right? So what we are getting here is minus 21 and 22, 30, right? And so we get minus 15. Definitely, area cannot be negative. So area is always taken as the absolute value. So we have to take the absolute value. So let me now introduce the sign for absolute. So it is the absolute value of this. And therefore, we can write area of triangle PQR should be equal to 15. Is that clear? Unit square. So I hope the steps are absolutely clear. The idea is first to find the equation of the normals, then the point of intersection. And since the triangle is scalene triangle, we can always use this particular formula to find the area of the triangle. Proof of the formula, I'll also provide you with a link on that. We'll have to following 2 more questions to practice. I hope that makes sense. The question here is, the tangents to the curve f of x equals to x squared minus 5x plus 4 at points P 1, 0 and Q 3 minus 2 intersect at R. Find the area of the triangle PQR. So we are given the function f of x as equal to x squared minus 5x plus 4. To find the tangents equation, we have to first find the slope at the given point, right? So let's find the derivative first. Derivative of this function is 2x minus 5. Now at point 1, P, x value is 1, so let's find the derivative at 1. Substituting 1 here, we get 2 minus 5, which is minus 3, and the derivative at 3 is what? Will be 2 times 3 minus 5, where 6 minus 5 is 1. So we get the derivatives at these 2 points. Now, derivatives means slope, right? So we can actually use the equation y minus y1 equals to m times x minus x1 to find the equation of tangent line. Correct? So let's figure this out. We'll work out on this side of the page. So at point P, which is 1, 0, we find that the slope at P is actually equal to f dash 1, which is minus 3. Right. So the equation will be what? Equation will be y minus 0 equals to minus 3 times x minus 1. Or we get y equals to minus 3x plus 3. So let's call this as our equation number 1. Now let's consider the point Q, which is 3 minus 2. And the slope at Q is 1. Therefore, the equation of tangent line will be y minus the y value, which is minus 2. That makes it plus 2. Slope is 1 times x minus 3. Perfect. So we get this equation. We can actually now write from here what is y equals to. Y is equal to, we have x minus 3 minus 2, or we can say y is equal to x minus 5. We'll call this as our equation number 2. Now clearly, when x is, we have got two equations. One is y equals to minus 3x plus 3. The other one is y equals to x minus 5. So from this, let's equate equation 1 and 2, right? We are equating both the y values. So we get from here x minus 5 equals to minus 3x plus 3. Bringing this to the left side, we get x plus 3x equals to 5 plus 3. So 4x equals to 8, x is equals to 2. And we know y is x minus 5, so y will be equals to, which is x minus 5, will be, x is 2, 2 minus 5. So we get y equals to minus 3. Okay. So the point R, which is the point of intersection, will be x value of 2 and y value of minus 3. Is that clear to you? So we got the point of intersection, and now we are going to find the area of the triangle. So we have 3 points. So we are given point P, which is 1, 0. We have no point Q, which is 3 minus 2. And then we know point R, which we just calculated as 2 minus 3. Now to find the area of triangle PQR, we can use the formula, which is equal to half of absolute value of x1 times y2 minus y3. So this goes in order, x1, 2, 3, right? So plus x2, 2, 3, 1, right? So y3 minus y1, okay, plus x3. So it is like 1, 2, 3, 3, 2, 1, right? So you have to see the order. Order is important here. So consider this 1, 2, and 3, right? So we have to go in an order, correct? That is important. So if I write x3, then it is 1, 2, right? So it is y1 minus y2. Is that clear to you? So that is the area of the triangle. Any scalene triangle can be, we can find area for any scalene triangle using this formula. So I can actually, you can actually pause the video, use this formula and find the area. We'll do it on the next page, calculation of this area. Let me copy the values once again. So we have this, these points. We have P as 1, 0. The point Q as 3 minus 2. And we found point R as 2 minus 3. Good. And the area of PQR is equal to half of absolute value of x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. So important to see that this order should be maintained, right? Otherwise you can make a mistake. Is that clear to you? Okay. So we'll just substitute the values and figure it out. So we get half of absolute value of x1. Start from here now. So x1 is 1, y2, y3. So minus 2 plus 3 plus x2, which is 3 for us, y3 and then 1. So 3 and 1. So minus 3 minus 0 plus 2 times y1 and 2. So 0 minus 2. 0 minus minus 2 becomes this. Clear? So that is half of, this is 3 minus 1 is 1. Minus of 3 times this is minus of 9. And 2 times 2 is plus 4, right? So what we get here is half of absolute value of 5 minus 9. Do you see absolute value is important, right? Half of, then this value is minus 4 absolute, which is 4. So we get 2. So our answer here is that the area of triangle PQR is 2 units square. Is that clear, right? So it is kind of important to put the absolute value. Area is always positive. So note area is always positive. Correct? So use absolute value while calculating area. I hope that makes sense. Is the normals to the curve f of x equals to 2 minus square root of x to the power of 4 at the points P 1 1 and Q 9 1 intersect at R. Find the area of triangle PQR. So that's the question for you. You can always pause the video, answer the question, and then look into my suggestions. So let's find first the equation of normals in this case. We are given the function which is f of x is equal to 2 minus square root of x to the power of 4, right? Derivative of this function f dash x is what? 4 times 2 minus square root of x times derivative of inside function, which is minus 1 over 2 square root x, right? So I hope by now this should be cube, right? 4 times 2 minus square root x whole cube times the derivative of inside function. Perfect. To find the equation of normals, let's find the slope at the given points. So we will just simplify this derivative. So we get this as minus 4 divided by 2 is 2. 2 minus square root of x whole cube divided by square root of x. Let me write here. Okay, so that becomes the derivative, general expression. Let's find derivative of tangent at P and Q. So at 1, the value will be, if I substitute 1 here, I get 2 over 1, 2 minus 1 whole cube, which is minus 2. And the derivative at 9, the x value of 9 will be minus 2 over square root of 9 is 3, right? So I'm writing straight away 3. And here we have 2 minus square root of 9, which is 3 whole cube. So that is minus 1. So that gives you plus 2 over 3. Is that clear to you? So these are the derivatives. That means they are slope of the tangent lines. Correct. So from here, we can always write down what is the slope of the normal, right? So at P, normal at P will be what? Normal at P will be 1 over the derivative value at 1, correct? Since the point P is 1, 1, so it is going to be negative reciprocal of this, right? So it is going to be half. And the normal at Q is going to be negative reciprocal of this, which is going to be minus 3 over 2. Is that clear to you, right? So that is important to understand. And now, let's find the equation of normals. So let's find equation of normals. Okay, so let's say at P, which is 1, 1, right? So that is this point. Here we know that the slope of normal is what? Slope of normal is half. And the point P is given to us as 1, 1. So let's find this equation. The equation will be y minus, we are using this for, y minus y1 equals to m times x minus x1, right? So we get y minus y1 is 1, slope is half, times x minus 1. So we'll cross multiply. So we get 2y, or we can keep it y minus, either way, 2y minus 2 equals to x minus 1. So we get one equation of the normal, right? Now let's also find the equation of the normal at Q. Point Q is given to us as 9, 1, and we just found that the normal slope at Q is minus 3 by 2. So that gives us y minus y value is 1 equals to minus 3 by 2 times x minus 9. Let's cross multiply. So we get 2y minus 2 equals 2. And this becomes minus 3x plus 27. Correct? This is 3x. Correct. So what we get here is these two equations. Let's call these equations as equation, let's say 3 and 4. I'll keep these as my 1 and 2. Okay. Now, 2y minus 2 is x minus 1. Here 2y minus 2 is minus 3x plus 27. So we can equate the values. So what you see here is we have same expression for 2y minus 2, right? So now we'll equate these two equations. So both are 2y minus 2. And therefore, we could now write this as x minus 1 equals to minus 3x plus 27. So let's rearrange. So we get x plus 3x equals to 27 plus 1, or we have 4x equals to 28, and that gives you the value of x as equal to 7, right? 28 divided by 4. So we get 7. So once we get the value of x, that is for point Q, we can now find the point Q by substituting this value and one of our equations, right? So our equation is y minus 1 equals to half of x minus 1, correct? We know x is 7, right? So if I substitute x equals to 7 here, we get y equals to, taking 1 on this side, 1 plus half of 7 minus 1, correct? So which is 1 plus half of 7 minus 1 is 6, or 1 plus 3, which is 4. So the point Q is the x value being 7 and the y value being 4. Is that clear to you? So we get the point R in this case, right? So they intersect at R. Sorry, this is not Q but R. So we have the point R, which is 7, 4. So we're done. We have found the point of intersection. And now the second part here is to find the area of the triangle PQR. So let's take it to the next page. We'll use the R as 7, 4. Here is the question for you. So what we found was that the point P is 1, 1, Q is 9, 1, and R is 7, 4. Correct? So these are the 3 points, and they definitely form a triangle. Correct? They form a triangle. Now, how do we find area of this triangle? This is kind of a scalene triangle, right? How do we find the area of this particular triangle? So if you want to sketch this triangle, it might look something like this, right? So we have 1, 1, right? So it is kind of a horizontal line, and 7, 4. So somewhere in between. So it is kind of like this, right? So that becomes the triangle where this point is P, this point is Q, and that is R for us. Correct? Now the formula for finding area of scalene triangle. So area of scalene triangle is what? Is basically half of, let me write down the formula here, then we are going to use this formula. So let's say these points are x1, y1, x2, y2, x3, y3. Then we kind of go in a particular circle, like So let's call this point as 1, this point as 2, and this point as 3, right? So the formula can be written as x1 times y2 minus y3 plus x2 times, so when you write x2, it is y3 minus y1 plus x3 times y1 minus y2. I'll provide you with a link where we have derived this formula. So this actually forms, we use trapezoids to find the area and then get this formula. Correct. So now we know these 3 points, right? We consider this to be 1, 2, and 3. We can substitute and find the value. I will also share with you alternate method, right, of writing this. Later. Let's use this formula first, and then we'll calculate. So we have half of, so 1 is the x1 value, 1 times y2, 1 minus 4, plus, now we have 9, and then y3, so this minus this, 4 minus 1, plus 7. 7 times the next number is, so when you say y3, 1 and 2, so when you write 7, then it is 1 minus 1. Okay. That is what you get. So we get half of 1 minus 4 is minus 3, and here 4 minus 1 is 3, 3 times 9 is 27, and that is 0. So we get half of 27 minus 3 is 24. So we get 12. And therefore, we know that the area of PQR triangle, right, is 12 units square. Right? So that is how you find it. Now there is another way of writing this and calculating, so I'll show you that calculation. So we could also find the area of triangle PQR, that is a quicker way also, is half of. So what we do is, we'll write this in the form of a matrix. Remember, area is always positive, right? So we write these points. P is 1, 1, so we write 1 and 1. Q is 9, 1, 9, 1, 7, 4, 7, 4, and then P again, 1, 1, correct? Now it's kind of a matrix where you can multiply these terms, they are positive, and when you do the multiplication for these, those are the negative terms. You see those negative terms, right? And first ones are the positive terms. That's what. So it's kind of a easy way of writing and then working out the calculations, right? So this is half of. So when you do this, 1, so we get 1. Plus 9 times 4, which is 27, right? Plus 7 times 1, which is 7, right? And the negative terms are 1 times 9, which is negative 9. 1 times 7 is negative 7. 4 times 1 is negative 4. Do you see that? So you could do this. So, and adding this, we get our result, and which is, of course, the same result. But we will always take the absolute value, right? So absolute value of all this, 9 times 4 is 36. I wrote 27 here. Right? So this is 36, right? Now we can do the calculations. 7 minus 7 is 0. And 36 plus 1 is 37. So we get 37. Take away 13. So which is half of. We have to take absolute value. Sometimes you may get a negative answer. So which is 24, right? And so you get 12. So same answer you get. So that is another way of writing and calculating. So some of you can use this method also. I hope that makes sense. Now we have a couple of questions which are like this for practice. So I'd like you to now copy this question, try it out. It's much simpler than what we did and I'll provide you the solution of this question in the next video. I hope that makes sense. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.